Let's talk about 5 common misconceptions and mistakes that people make when it comes to module federation and micro-frontends. I'm Jack Harrington, and this is Blue Collar Coder, brought to you from scenic Portland, Oregon in the fall. So the first one we can talk about right here, and it's a misconception that people have when it comes to understanding the relationship between micro-frontends and module federation, and it's probably something that I've added to the confusion on because I've kind of mixed and matched those things in the past, but they are 2 separate things. So module federation is a code transport layer. That's all that it does. It gets code from one application to another as a runtime dependency. And micro-frontends is an architectural style about sharing code between applications, and in particular, front-end UI code. And there's 2 core tenets when it comes to what a micro-frontend is. And that's one, that the micro-frontend needs to be cross-platform or platform agnostic. And the second is that it needs to be a runtime dependency that is independently deployable. And module federation obviously helps with that second one. It makes that code independently deployable between those applications, but it doesn't help at all with the first one, which is to create that platform agnosticism of the component itself. So let me give some basic concrete examples here, and we'll create a module federation stream, a pipeline between our applications. And we'll have as an example 2 applications. We've got home and we've got PDP. And now in this case, in the simple case, both of those are written in React. And that home page wants to act as a remote. It wants to share the product carousel with any other application. And that PDP page wants to consume that product carousel, so it's going to act as the host. Now, the nice thing here is that both of those applications are written in React. So there's no real work to be done to share this product carousel micro front end between these 2 applications. The home application can simply share the product carousel code, and the home page can simply consume it from that module federation code sharing stream and render it just as it would any other component. Now let's take a slightly more complex example. The home page with the product carousel is once again written in React, but in this case, the product detail page is written in Vue. So how's that going to work? Well, in this case, the home page can vend the product carousel onto that stream, and it can also vend a shim, a DIY shim function that uses React to render that product carousel into any element. It's actually a pretty simple function to write. And so what the Vue application is going to do is consume that shim. That shim is then going to bring in React because it needs to have React in order to render that React component, and also bring in that product carousel. And then with that, you can mount that product carousel on any element on the page, and away you go. But of course, that's a DIY solution, and you're not going to want to do that for every single component that you have. And also there are some downsides, there's property maintenance and all that sort of stuff that DIY solution doesn't cover. So what's a better way to do that? Well, a better way to get that platform agnostic behavior that you want when it comes to micro-frontends is to use single SPA. So how's that done? Well, let's talk about that same scenario where you've got, again, the home page is React and the PDP page is Vue. But in this case, instead of doing the DIY shim, the home page parcelizes the product carousel, which makes it a platform agnostic piece of code, and then publishes that to the stream. The Vue app then consumes that parcelized code and uses a single SPA client to render that parcelized component onto the page. And single SPA does all of the work of making sure that that React component looks and feels just like any other single SPA component. Now, that's a little bit of extra stuff if you have React in all of your locations, but when it comes to getting your code between application frameworks, this is the best way to go, and single SPA is a fantastic library. But of course, this understanding also short sells module federation, which can do a lot more than just share front-end code. It can share any type of JavaScript between applications, and that could be configuration flags, I18N strings, utility functions, data access libraries, what have you. You can put anything onto that module federation stream and get it going between 2 applications. So it's important to understand what module federation is and the scope and breadth of what it can do, and also what micro-frontends are as an architectural style and how your code fits into that model. All right, now to get into the next common mistake or misconception that people have, we need to jump back to the office. All right, the next common misconception that people have when it comes to module federation is that you're implicitly sharing state when you share out this code. So in order to demonstrate this, I'm going to need to create two applications, of course, and so I'm going to go and create two different shells. All right, now over in this first shell, I'm going to do pnpx, and I'm going to do create mf app, and that's going to set up an app for us. But first, you have to give it a name. I'm going to call this one host. It's going to be an application on port 3000, and it's going to be React and in JavaScript, and I'll use Tailwind for that. And then I'm going to go into that directory, and I'm going to yarn and yarn start if the yarn is successful. That's what that double ampersand's about. And then over on here in the other terminal, we're going to do pnpx again and create mf app. And over here, we are going to create our remote app. So we'll call this one remote. Again, it's an application, port 3001, React, JavaScript, and Tailwind. And we'll go into the remote directory, and then again, yarn and yarn start. So what are we going to do? How are we going to demonstrate this? Well, we're going to go and create a new file. So we're going to go create a new file, and it's going to be called counter.jsx. And when you know it, we're going to go and create a counter. So let me see if I can speed run counters here. I'm going to bring in React. I'm going to bring in use state. And that's all I need for a counter. And then I'm going to export a default function called counter. And then it's going to have a count and set count. Ooh, wow. Okay, well, GitHub Copilot's going to help me speed run a little bit here. Good, starts at 0. Cool, all right. Return and div. And we're going to have a div that says count is the count. And then we're going to have another div that has a button in it that then on click will add 1, set count to count plus 1, count plus 1. Okay, and that's a Sesame Street joke for y'all. Add to count. I don't know if you get Sesame Street wherever you are. It's a good show. All right, so we've got a counter now, and we're going to go back into app, and we're going to bring that in. Import counter from counter. And we will put down here the, let's keep remote. That's important. And then we'll do counter like so. And I'll go to port 3001. And now I've got our count at 0, and we can just add to count, and away we go. Let's make it a little bit nicer so we can kind of see that it is this thing. Nice thing, we have Tailwind around, so I'm just going to get a bit of border and make that border blue and give it some padding and then give it some rounded. Yeah, kind of make it look like a thing. Oh, yeah, okay. So now it kind of looks like an MFE, right? Like a micro-Frontend. So there you go. Looks good. And hey, if I hit refresh, right, what does it do? It goes back to 0 every time, right? Because it's a new page load. And all we have is that state, and that state always starts at 0. So let's go and take the same thing and expose it first. So I'll go down here to Webpack config and go all the way down here to the plugins and module federation plugin. And I'm going to expose the counter from source counter. And now I've got to go into my remote shell and then yarn start again. And I'm going to go over to my host and then go into its Webpack config and go scroll down again here. Let's see, I got remotes, and I'm going to say remote at, no, it's giving me the URL here. So I'm just going to get remote entry. That's what it's looking for, is this manifest of all of the modules that it's exporting. You can actually see as you go into here, I can search for counter, and it actually has, counter in there. All right, so now let's go and add that on there. So at, and then give it the URL. And that's going to connect these two applications. So host is now going to be connected to remote as soon as I restart it. So let's do yarn start again over here. And now when I want to import, I can just import the counter from the other application. So let's go back over here to our host app, go into the app. And then I'm going to bring in counter from remote counter. Let's get the uppercasing right. And in this case, it's host. Make it all uppercase. And then put that counter in there. And away you go. So let's take a look. So now, yep, there you go. On 3000, I got the counter on host. And then on 3001, we've got the remote. And if I go and add 6 over here, I'm going to go over to host and I'm still at 0. And so this is a misconception that some people have when it comes to module federation and what it's capable of doing. In this case, all you're doing is just sharing this counter code. You're not sharing anything more about it. You're not sharing any kind of state. And the fact that this code is served from a running app doesn't mean that there's any implicit connection between the code and the server that served it. So how would you share a state between these two applications? Well, there's all kinds of options for that. There's Firebase, there's GraphQL subscriptions, there's your own REST API with WebSockets. There's all kinds of ways to share a state, but none of it is going to happen implicitly because these modules are federated and you're sharing this piece of code. All right, so this brings me to the third misconception or mistake that people have about module federation, and that's that when the app goes down, that code is going to be broken, which is not quite a misconception, but it's not quite right. So let's actually try that out. Let's go over here to our remote app, and we're going to stop it. It's dead, right? And so now if we go over to our host and we hit refresh, we're going to die because we go over here to the console. We can see that we couldn't load that script. And so I get this question a lot. Well, what happens when the server goes down? And this one is, again, partially on me because when I demonstrate module federation, I always do it using apps like this. And that's because I want that code to regenerate quickly. But that's not actually the way that you deploy this. So let's go back to our terminal. And I'm in remote. And I'm going to use yarn build and then dev. The reason I'm using dev here is because I want to have the nice file names. And if you used yarn build, you'd get the kind of chunked up file name. So, all right, so let's open up that dist folder. And we can see that we have the remote entry. We've also got the source for the counter and everything else. And this is actually what you deploy to S3 or an asset store. Basically, it's a static application. You don't need a server to run this thing. So if I wanted to imitate what a static asset store would do, all I need to do is use a dumb server application. I'm going to use servor. So to imitate this, I'm going to go into that directory, and then I'm going to do port equals 3001 npx servor. And that's basically going to do essentially what an asset store would do. So now over on remote, I can hit refresh and localhost 3001. It works great and everything's fine. And if I go back over here to our localhost 3001, if I hit refresh, it works. And that's the way that you deploy federated modules. You do it to an asset store like S3. And if S3 goes down, I think a lot of us are going to have a snow day when it comes to web development. So going on to misconception 4, there is a related issue when it comes to the stability of these things. And that's the misconception that people have that module federation modules are versioned. And they're actually not. And that's actually kind of the point. You want that runtime dependency to get updated immediately. So there is no versioning on them. And that can add to some risk and potential errors. So let's talk about that potential risk. And then I'll show you a way to mitigate that, at least in React. So let's jump over back into VS Code. And I'm going to stop doing my servor and go back in the main directory. And then in that remote directory, I'm just going to do yarn start again. So let's say that I want to add in the app name to my counter. So I'm going to go down here to my counter, and I'm going to add a property called app to my counter. And it's going to have up at the top here a div and then app.name. So if I'm over on localhost 3001, I hit refresh, it's lights out, game over. And why is that? Well, let's go into our console and we can see that it cannot read the properties of the undefined reading name, right? So we're looking at for app.name, and app is undefined. So let's go over to app, and then we'll add an app equals name, and then remote, refresh, and now that works. Awesome. Okay, great. But let's just say that we push that to production and then to S3, and now the host team over here, they do a refresh on their page and boom, lights out, right? Why? Because, well, in this case, again, cannot read property name of undefined. So they didn't know that they had a contractual change here in what the contract of that React component, that counter component was. So let's go back over into our host, and obviously we can just do a quick fix here. We can just add on that app name is host and refresh, and we're great. But that actually doesn't address the underlying issue, which is we want these components to be safe and not take down the whole page if that contract changes. So let's make this break again. And let's try and fix the page at this point from this broken state. And the way that we're going to do that in React is we're going to use error boundaries. So an error boundary is a component, and it basically catches any errors that are found in the running of components that are encased within it, essentially. Now, the only bad thing about an error boundary is it has to be a JavaScript class, which you may or may not like, but this is the only case that I know of in React where it has to be a class. So I'm just going to copy and paste in their example code, and I left a link to that page in the description. And so the big things here are that you have a React component. Constructor creates a state where you store whether you've had an error in your component. And the way that you get that error set to true is you get this derived state from error that is percolated up from this component did catch automatically by React. And component did catch allows you to go and do something like, for example, log an error to my service would go and log an error off to Splunk or something like that. So let's just comment that out. And I'm just going to take this error boundary as is. It's going to go, and if it sees an error, it's going to just put out this H1 if something went wrong. And I think that's going to work well. So let's just drop it in here around counter and then go back to our host page. And yeah, at least you're not blowing up the whole page. And that's the important part. And all I did was just paste in the code from the React documentation and just comment out this non-existent log error to my service, which you should go and replace with something that would log an error to your error tracking service. Okay, so our fifth and final mistake or misconception when it comes to module federation is around TypeScript. So I need to restart everything with TypeScript this time. And so again, I'm going to go and create two terminals. And in that first terminal, I'm going to again do pmpx, create mfapp. If you don't have pmpx, you can always just use mpx. I'm using pmpx because it works on Windows. And then I'll pick host again, application, 3000, React, and the only difference is I'm going to pick TypeScript this time, and then Tailwind. And again, I'm going to go in there in that host directory and I'll do yarn and yarn start. Similar kind of thing over here in this other one. I'm going to do pmpx, create mfapp. Again, yes. And again, I'm going to pick remote. And then I'm going to pick application, 3001 this time, React, and again, TypeScript and Tailwind. And then I'm going to go into remote and start yarn and yarn start. Okay, looks like both applications are up and running just fine. We got host on 3000 with TypeScript and remote on 3001 with TypeScript. Okay, so let's go and start off our example by going into our source directory, and I'm going to create a new one called my user mfe.tsx. So we're going to have these micro-frontends, and they're all going to take user as a required property. So let's go over to our app, and we'll import that. And so it's giving me the red line because it's telling me that there is no user property on here yet. So in order to satisfy that, I'm just going to put in my user. And looks good. Let's go to try. And there you go. So now I've got my MFE going in there, and that's great. I can take out this stuff. It's a little bit distracting. Looks good. Awesome. So now we want to get this over to the host app. So again, I need to go over here to our Webpack config and scroll down, go to exposes, add / and then my user MFE, and then give it the source file, which is going to be that TSX file. And then I need to relaunch our remote. Okay, that's looking good. So now let's go and get the location of that remote entry. And I'm going to import that into our host. So let's close down these and then go over to our host and go into Webpack config. Scroll down to remotes and then add in remote and then give it the name of the Federated module, which is remote at, and then the remote entry.js location. Looking good. And now let's go into our import and app. And we're going to basically do the exact same thing that we did in the other one. We're going to import my user MFE from, in this case, remote, and my user MFE. And I'll scroll down here and say user equals Bob. And now I've rebooted the server and it works just fine. So this red squiggly is telling us that TypeScript doesn't know the types of that module. Remote module, my user MFE, can't find those types, right? So, well, why is that? Well, the misconception or the mistake in thinking here is that the federated modules contain any type information from TypeScript. They don't. They're just JavaScript. They're just compiled JavaScript. So let me prove that to you. I'm going to go over here into our remote, and I'm going to close that out, and then go into remote. And I'm going to do yarn build again in dev mode. So I'm going to bring up the myusermfe tsx.js in code. But the code is kind of obscured a little bit by this eval stuff. And the reason for that is that dev tool is turned on in our Webpack config. So I'm going to go over here to our Webpack config and then scroll down and just add in dev tool is false. And then go back into here and yarn build again. And now let's take a look at that file. And yeah, this time it looks like it should, but this is basic JavaScript, right? We got var, myusermfe, and we got the import of the create element from React. And then you can see us actually creating that React element. This is just basic JavaScript. There's no type annotation on this at all. So that's why you're not seeing any typing over on app.tsx. None of that is exported when it comes to federated modules. So how do we go and fix this? Well, let's go back over into our host, and we're going to basically go and add types for remote myusermfe. So the way that I'm going to do that is create a new folder in here called @types, and I'm going to give it the first level name of remote. And then I'm going to give it another directory within that called myusermfe. And then within that, I'm going to create a new file called index.d.ts. And in there, I'm basically going to bring in React and then define what myusermfe is. It's a React function component that takes a user as a string. And there you go. And it exports it as the default. But we're still not working. So why is that? Well, we got to go and create a TS config in our directory, which we don't have. So let's go over to host. And then within host, I'm going to do tsc init. Now it's going to create a TS config file. And then I'm going to go and change JSX because this by default doesn't allow for JSX. I'm going to change that to React. And then I'm going to go find the location for paths. And then I'm going to go change this configuration for paths to say that we want to look also at the source for types, which is what that directory that we just created. So let's go back over here and we can see that now we have proper typing. And as we take this out, we can actually get like real typing here. So it knows that there's a JSX attribute and we can say, hello, and there you go. But that's not quite a complete solution, right? What you really want is you want to be able to define the contract of an MFE and share it between these two systems such that when that contract changes, the remote will fail on compilation or the host will fail on compilation. And the way that we do that is, well, one way to do that is to create a shared library between those two. So let's go and create yet a third terminal. And this time I'm going to do pmpx, create mfapp. And instead of creating an application, I'm going to create a library. And we'll call this one mfe-shared. And we'll create it as a library. And then we'll go into mfe shared. And then into that, I'm going to add React and React DOM. as well as the types for React and React DOM. So I'm going to add types for React and types for React DOM, both of those in development mode. And now let's go take a look at what our library actually has. So let's go here to MFE shared. And in the source directory, there is simply just an index.ts file. And all it has in it is just a simple function. And I'm going to replace that with a definition for our user MFE. So again, the user MFE is going to be a function component that has a username as a property. Okay, cool. So let's build that. And then in that directory, we can see that we now have a dist directory. And within that, we have this index.d.ts file. So let's take a look at that. And that actually declares that type of user MFE. All right, so this looks good. Now we've got this definition for what a user MFE is. So let's go and do a yarn link in here. And that's going to allow us to then link that into both the host and the remote. So let's go and first off go to the remote. And then do from here yarn link MFE shared. And then go into the host and also yarn link MFE shared. And so down now in the remote, we can go into source, go into my user MFE, and say that we are a my user MFE. So we get that definition from MFE shared, so we can now replace this with that definition. And that works just fine. So let's go and yarn start on that. Looks like it's up and running just fine. And now we're going to go and do the same thing over in our host app. And then we go into the types, remote, my user MFE, and go into here. And we can just bring it in and say that we are a user MFE. And there we go. Now let's do it in host. And it looks like everything's running just fine. But of course, that's not really the point. It was always running fine. It was just the types. And so this allows you to share those contracts between the host and the remote. And when the host and the remote are compiling that TSC compile phase or Babel compiling TypeScript, then you can make sure that the remote components all have the right properties and that the host pages are looking for the right properties and send the right properties to those components to avoid those runtime issues like we saw before when we added properties to a component but didn't tell anybody that we had done that. Okay, well, I hope this video helps you understand a little bit more about how module federation and micro-frontends relate. But of course, I'm sure you have some questions, so be sure to put those in the comment section down below. And of course, in the meantime, you can hit that like button if you like the video. And of course, hit that subscribe button if you really like the video and get notified the next time a new Blue Collar Coder comes out.